77 tons in 2023, and one is about 55,634 tons in 2019. Now, these are the future aspirations. Chandra plant aspires to achieve more than 50% PSR, and Wadi plant aspires to achieve more than 30% PSR by 2028. Now, we are, as I told you, we are underway, set up new and existing processes that we get Wadi. So, Chandra will have a because it was not having one, and Wadi we are going to expand our. We're also going to have bypass and expansion of coprocessing infrastructure is also porting in both of the plants. We're going to have including bypass to both of them. Now, this is the way forward. GP is expected to provide solutions for moving around, we approximately 1 million tons by 2028, and out of which 60 to 70% will be definitely coming from SPF or RDM from every country. We will be heavily investing, as I said, in processing and fan acceleration and chloride bypass system. We are also going to focus on manpower requirement and creating some continuous sourcing supply because we need to train people to understand what we need to get into our plants. So there are certain things which we would be requiring help for. First, there has to be a higher government event for setting up total waste management. So this becomes very important because our plants are located in nearby villages and we need, so we will be setting up new levels of required tier 1 also introduction of higher landfill tax by the government to enable diverting large volumes of waste to landfill. Therefore, there can be a concept of circular economy. Training and capacity building for waste management stakeholders to ensure effective collection and segregation. So these are 4 things which we will be also doing support. Thank you.
Very good. Very good. Any questions? We can take a question at the end of the presentation, someone wants to make a short summary. Can the student raise hand? Who are the students here? Yeah. Excellent. So maybe this side, anybody will volunteer for this lady? Yeah. This time, just half a page. Summary. Excellent. I know that. You stay there. Okay, at the end of the session, you can answer it. Good afternoon. We are from KJSIM Limited.
I can do it.
Both our group profile. My home group is established in 1998. Plant capacity of 0.2 million tons per annum. Now we have grown up to 15 million tons per annum. Apart from cement, we are in power sector, education sector, construction, and power media. About our group, I already told it is 15 million tons per annum. In that, our plant is 3.2 million tons per annum cement capacity and 0.2 million tons per annum clinker capacity. So, you see the technology of plant. These are the technologies. All our energy efficient systems we have installed, like VRMs, vertical roller mills, and the pyro process is supplied by Holstrom and FL Smith. And coming to the co-processing, we have solid AFR system supplied by Sangvi, capacity of 30 tons per hour. The liquid AFR supplied by PH1 and Alpha, with a capacity of 8 tons per hour. We have our own solar power plant, the capacity of 11.2 megawatts per hour, and we have a waste heat recovery, the capacity of 7 megawatt. This is the power consumption trend for last 3 years. This is the power consumption for cement, overall cement. And this is the heat consumption for last 3 years. Coming to our presentation, we have applied for the category number 4, establishment of pre-processing and forecasting of alternative fuels. So coming to the liquid air fuel system, we have already supplied, as I told, supplied by PH1. There are two types of firing liquid. One will be at the kiln. It will be around 1400 degrees centigrade in the kiln. Whereas calciner, the temperature will be around 300. We have a capacity 5 kL per hour in calciner and 3 kL per hour in kiln. So presently we are using in the calciner around 3 to 4 kL per hour. So this is a system. We have established the system latest technology at double layer SS tank. So if there is any spillage also, that liquid, as it is hazardous liquid, it cannot go out. So we have made a double layer SS tank and the nitrogen blanketing system for storage, because it is highly volatile material, so chances of catching fire. So any volatile comes, that also we have a volatile VOC system and the automatic foam putting system, any abnormality or anything. So and the self-cleaning system for strainers. Previously, old system having you have to clean the filters manually. Now we have given self-cleaning system for strainers with DP. This is the system, liquid power system. These are the tanks, double layered. This is the nitrogen generation plant. This is the fourth generation unit. This is the volatile organic compound. This is the water control system, really liquid having higher smell. So we have provided curtain to avoid the so this is the feeding point. Actually, calciner we have just cool liquid air for 90 system. This is the solid air for we are feeding. This is the liquid air for acceptance criteria. Already speaker before talk. This is the criteria. This is all or in the limit, or if it comes, then only we are accepting the material. Otherwise, we are rejecting the material. These are the out of equipment for analyzing the liquid quality. These are the TSR. Here last 6 months or 9 months, there is average is 2.85% of TSR and 8,600 tons consumed. This is the hazardous liquid. Coming to the solid air part, it is supplied by Sangvi with a capacity of 30 tons per hour, and it is we have a shed capacity around 6,000 meter cube capacity. Push flow material storage for time being. That is 300 meter cube. These are the equipment, the solid air power system, and we have provided fire protection as well as water sprinkler systems. This is the shed, the capacity of 6,000 meter cube. We have commissioned recently in the month of June. This is the material stored, and this is the push floor capacity of 300 meter cube. This is the dosing drum for dosing of the material to the conveyor. This is a wave feeder, and after wave feeder, it will go to wet conveyor, and then there is a double block to control the air entry, false air entry. This is the overall circuit of solid air processor. This is a solid air for before solid air system comes, we used to mix some of the waste along with fuel. After that, we have increased the TSR from June onwards. Now, last month our TSR solid is 12.7% and 10,000 tons last month consumption. So overall TSR solid and liquid together is October 16.18% TSR. Some of the awards we got last year on energy front.
Okay, thank you very much.
Thank you.
Good evening. My name is Chari. I represent a company called Anthony Lara Enviro Solutions Private Limited. Anthony Lara Enviro Solutions Private Limited is part of Anthony Waste Handling Cell Limited. And Anthony Waste is, I'm proud to say that Anthony Waste is the first Indian public listed company. We started our journey to waste around 2.5 decades ago. We started with collection transportation, and the first process project we backed from BMC, what we call as Municipal Corporation of Greater Mumbai, the year 2009, and we commissioned our plant in 2012. And till today, we have processed around 1.6 crores of MSW last 11 years of our operation. And we have basically two technologies in Kanjurmarg. One is material recovery facility and composting, which is limited to 1,000 tons per day, and 4,500 tons of mixed waste is taken to a technology called bioreactor. So bioreactor basically looks like a landfill, but we recirculate leachate to generate landfill gas, and from landfill gas we create our own electricity. Presently we generate around 2 megawatt, which is used for our captive purpose. And each cell has got a limitation of around 15 to 20 lakhs tons of MSW. And after 5 to 6 years, we start biomining of the cell, that we call post-sorting and also biomining. So when you mine it, 60% of the RDF is generated. You generate soil conditioner, very negligible fractions of recyclable. RDF again was a challenge to be sent to cement factories because cement factories were reluctant to take RDF the original form. So we approached cement factories and asked them the quality they require, and we set up a pre-processing plant at our site itself. We have at least the 10 lines of shedding units, each of around 25 to 30 tons per hour. We do primary shredding, secondary shredding, and then again we take it to screening, where we screen the material to less than 80%. We also have a dedicated windrow system for RDF, where we dry and bring down the moisture to less than 25 to 30%. And that way we were able to cater to the demand, and we have been supplying to at least 12 cement plants from the city of Mumbai. And per day we are at present we are supplying around 600 tons. And this year we are aiming to escalate it to more than 1,000 tons. That is what Kanjurmarg is doing. We also have put up a waste to energy plant in Mumbai, where we have recently, which was inaugurated by us, and we are generating there around 14 megawatts of electricity from 700 tons of the MSW being received, which is also pre-processed. Certain portion we generate compost, and the SRF fraction goes to the WT. This is what, as far as waste processing is concerned, we are doing at present. And we have the Mumbai contract. We are planning to change the technology, enhancing with improving the RDF protection, and also trying to bring in pellets. We have already have small quantity set up on a pilot basis where we have been able to successfully generate some 100 to 150 tons till date on pilot basis, where we are generating pellets from the coarse plant of composting, not from RDA, from the coarse plant, where we are able to fibrous materials which gives a very good calorific value of more than 4,000 GC, 4,000 to 4,500, and during monsoon it may come down slightly by around 500 to 800. This is what is the present scenario, and we have a small video. I think cut short the time of presentation. I ask you to explain it. Yes.
India is the world's fastest growing major economy. The increasing industrialization and urbanization and changes in the pattern of life, which accompany the process of economic growth, give rise to generation of increasing quantities of waste, leading to increased threats to the environment. India's current CO2 emissions are 2.88 gigatons, the third largest carbon emitter in the world. In addition, open dumping grounds emit greenhouse gases and contaminate groundwater. COP26 2021, a UN climate summit, has declared our planet in a code red for humanity zone posed by climate change. We at Antony Waste Handling Cell Limited acknowledge these major waste management concerns and have devised a system that is up to date and provides solid waste disposal solutions. We are amongst the leading players in the Indian municipal solid waste management industry. We are the first MSW management company in India listed on BSE and NSE. Our mission to work with governments, corporations and industries to preserve and protect the environment through safe and efficient waste management. Our vision to diversify and provide solutions in various waste sectors pan-India, creating a better future by significantly reducing carbon footprints, implementing latest technologies pan-India. We have executed 25 plus projects and have worked in over 9 states in India. Our current portfolio consists of varied projects pan-India. We have extensive technology tie-ups in the US and Europe. We offer the following services: collection, transportation and sweeping, processing and disposal, waste to energy, biomining and disposal of legacy waste, construction and debris, primary collection vehicle, collection, FCTS, after the waste is collected, it is weighed with the electronic weighing bridge and disposed in the waste processing site. Mechanized sweeping. Along with collection and transportation, we also provide mechanized sweeping. Integrated Municipal Solid Waste Management. Waste to Energy. A 14-megawatt waste-to-energy plant at PCMC is being set up and will be fully operational by 2023. Biomining and disposal of legacy waste. The waste is processed by segregation, wherein we get RDF, compostable material, soil and recyclables. All these materials are disposed of in a scientific manner and the land is cleared of legacy waste. Construction and debris. Anthony Lara has been formed to undertake the prestigious Integrated Waste Processing Project for Municipal Corporation of Greater Mumbai. The project has been awarded to us for 25 years and currently handles majority of the entire waste of the city of Mumbai. It is the largest single location waste processing project in Asia, entailing a capacity of processing up to 7,500 tons per day of municipal solid waste. Our project infrastructure in Mumbai Municipal Corporation Integrated Municipal Solid Waste Management has material recovery facility, mechanized aerobic compost plant, bioreactor plant, biomining of bioreactor landfill. Material recovery facility has been imported from USA from a leading company that has installed MRF worldwide. MRF is used for segregation of municipal solid waste into multiple fractions. Mechanized aerobic compost plant. In the compost plant, organic fraction coming out of the material recovery facility is processed aerobically by forming windrows and turning the waste with a windrow turner.
We are in the city of the nearest cement factory from Mumbai are from 5 or Bali, longest being in 1,020 kilometers distance. So transportation cost is a very huge, and to keep RDF which suits to your production, to your requirement as a safe so that you can ready to fuel it. That is a process for this, a process for work. Because when you are going to shred it, you are going to do primary shredding, secondary shredding. Then again, we have challenges of sizes. So then you need to do screening. After screening and Bombay, what happens? The waste has got a high moisture because of the humidity. So normal, non-seasonal, non-monsoon today, you have a moisture of nearly 40 to 45%. So in order to bring down that moisture to less than 20% or 50%, we again need to create a windrow pad, which is similarly what we do in compost. You have to keep aeration so that you can reduce moisture. So that all costs becomes a challenge for us as a operator. But we are trying to meet the requirement. Yeah. But going forward, the price of fossil fuel is going up. And this AFR compared to the fossil is very low. So I think cement companies should have a broad spectrum, spend on AFR, and they also bring down their OPEX cost, and it will be a win-win situation for them.
Sir, actually we are facing, facing water issues. Maybe Mumbai or some flood areas they may not complain, but if it comes to cement plant area, neighboring villages are scolding us like you are bringing the dump yard material to us, and you are spoiling our environment like that. Complaints are coming to overcome the odor issue.
That depends upon the quality of RDF journey. See, if a operator is just segregating waste and giving you the non-recyclable solution without shredding or without any segregation and with some portion of organic, you will always have this kind of problem. If you are going to if you are going as an operator, if I am going to pre-process the RDF suitable to the requirement of cement company, then I don't think I have that should be a problem because I've been supplying AFR to at least 12 cement companies in India.
Okay, but still there is a moisture after your pre-processing and all those things. The moisture is not of less than 25%. Is it
15 to 20%? 15 to 20%
15% is the minimum you are saying. Maximum what is the moisture?
Maximum depends upon the season.
That's what. Suppose in season it's 20%. The moisture, whatever it is in the plant and water is. So and that's also already used for
Thank you.
So now we have the last Ghosh.
Good afternoon to everybody. Myself, Manoj Kumar Suri. I am representing JK White Cement, Rajasthan Water. We are the first plant to utilize AFR as hair scale. You know already that the grey cement always has scope for utilization of AFR, but JK Cement Oil has tried to utilize the AFR as hair scale. Internationally, you can just go and search for this AFR utilization in white cement. The percentage ranges from 2 to 3%, but we have got two things at our hand. One is 2000 TPD and one is 600 TPD, and we have reached the level of 20% ESR, one of the things, and around 15% in the second field. And we are further. So, these are the contents. A brief about JK Cement. JK Cement is creating manufacture of grey and white cement. Our grey capacity is 21 million tons per annum, and we are heading up to 25 per annum. Coming up still two more plants. And white, we are the largest white cement. We have got our units at Rajasthan and we push one could be at our Africa unit. We have got two lines at Kotak, Rajasthan. One has a capacity of 0.8 million tons per annum and it has 0.47 million tons per annum. These seems small units, but if you compare to the white cement, as we are getting the demand largest production. And we are achieving a TSR of 8.8% in line 1 exists 2000 TPD and around 12% TSR, STSR, small thing around 600 tons per annum. This is the three system. I think almost all the cement plants you will see grey, white. You are started with the basic started with system, and this is the same system that we have got the leach machine, we have got the hopper, then weight feeders, two tap gates, and one emergency the gate, and then these two cancel. And nearby we have got feeding point for liquid. The liquid waste we are feeding it direct from the tank, and we have got fill. And just like conventional grey cement, instead of cooler, we are having cement is quenched instead of cooling. So this is go to white cement, and chemistry wise, iron content that we maintain in our cement is too less. It is less than 0.3%. The physical is copper and weight reduction that we got for solid filling system. And here we feed only industrial waste, industrial other. These are some of the best figures that we achieved. In our, we have achieved up to 12.5% in December. Our figures is around and around 90% in our small 600 tons per day. Our journey had started in 2022. We are very apprehensive on utilizing AFR because this was very new to us because in white cement, the whiteness of the cement that we need to maintain is around more than 88%. If I give you a brief regarding what the whiteness means, if you are seeing the white tile, we consider that tile equal to 100% whiteness. And we cannot go the whiteness below 88% of that whiteness. So that quality of whiteness we need to bring to the cement. That is what was one of the main reasons to avoid the usage of AFR. But because of the higher cost, variable cost, I think we have taken the risk of utilizing the AFR. And our journey has started in August 2022 last year. And then subsequently started first utilizing it through the coal route. Then we have installed the Sadhan system at our filter, and we have done further modifications based on the availability of waste. We have got Kare distribute, and then we have started utilization of mixed AFRs, liquid AFR. This is the quality control of the selection criteria that we use for white cement. The first criteria is the ash content in the AFR. It's a typical one because this has no limitation in grey cement. In white cement, it's one of the critical parameters, the ash content of each of the waste that we are using. And so the preferable waste to choose between the liquid AFR, but due to the temperature profile that the waste has on the calciner, and because of the calorific value that is available in the market, so we cannot directly go for the white cement. So we have identified the solid AFRs having less ash content in it. And then we have started utilizing. Mostly these are the districts and all other waste our end we have identified. And further we will be having we have explored utilization of biomass, ash content more than 3%, and we are in process of utilizing waste having higher ash content as well as higher iron content. Because iron has got direct impact on the color of the cement. So this is the typical selection criteria for white cement. And this is the design of our system. For it, we are designed for 5 tons per hour, and liquid we have focused around 14 tons per day. That is the maximum that storage. These are some of the modifications. Earlier, we thought that there will be, since we replaced only the powder kind of waste at our end, so we have started replacing industrial waste. But in the industrial waste, the powder, then also we have faced several kinds of jamming shoot, and that we have modified textile. And the liquid scenario was similar to the conventional that we have got at every cement plant. Earlier it was direct utilization of screw pump and firing it calciner. Now we have got filters after the jamming issues and all, and we are soon going to have a full-fledged liquid AFR feeding system. And these are some of the improvisations done at the solid feeding system. We also introduced airlines and separate focus holes for the calciner because we had anticipated that this jamming problem was occurring only for the plastic waste and grey cement. These are some of the figures. Last year, we can see figures of TSR well below 1%, and this year we have reached maximum of 8.8%. And in line 2, it was less than 2%, basically by utilization of liquid hazardous waste. And this year we have crossed 12%. These are the waste-wise utilization of AFR at versus Sultan. So basically, we have got the carbon waste from petroleum industry, maximum utilization of that and the liquid waste. These are the way forwards. We are already halfway through the construction of storage shed, that is storage, and we will be having increased capacity thereafter. And equipment system will be commissioned after the installation of solid waste. Then the installation of AFR lamps and particular explaining new ways of utilization of AFR. That's all. Thank you.
Okay, fine, thank you, Manoj. So now let's go. Yeah.
Good afternoon to all of you. I am Manish Samdani, heading Quality Control Department of Udaipur Cement Works. Thank you for sharing alternate fuel and raw materials for processing team. We are from Udaipur Cement Works. Udaipur Cement Works Limited is one of the leading cement manufacturing companies, which is located at Lexington City, Udaipur. It is also a subsidiary company of JKSP Cement. Our clinker production capacity is 3.0 million tons per annum. Cement production capacity is 4.7 million tons per annum. We have a 13 megawatt waste heat recovery system. Also, we have 14.45 megawatt solar power generation, along with a floating solar, which is first in the cement industry, which is located in our mine street. We have a 6-kilometer long overbelt conveyor system, which to source raw material from mines to plant. Udaipur Cement Works Limited manufactures cement under the brand of Platinum Heavy Duty Cement, which is especially particle size distribution technology. We have ISO certification of 14,001, 45,001, 50,001, and 9,001. We have also certified NABS certified lab, and we are following cement manufacturing under following BIS license 43, 53, CPC, SRPC, and composite cement. Now talking about alternate raw materials which we are using. So as we know, raw material consumption, alternate fuel consumption is timely needed, important in every cement plant. So since inception of our company, we have total consumed 62,844 metric ton of liquid AFR from last 2018 to September 2023, including we have consumed solid AFR 2,712 metric ton. We are basically co-grinding with coal. We are using solid AFR, which is co-grinding with coal, and we have well filling system. Now this is a graphical presentation which we have consumed AFR consumption in 2020-21. Our consumption was 6.7%, and now 2022 up to September, 9.3%. This is our facilities liquid for AFR filling system. So we have separate unloading system and with a centrifugal pump, fully mechanized pipeline path for transport material. Now we have two storage capacity tank. One is 55 KL and another is 750 KL with recirculation pump. This is our sampling procedure. This is a very important part for AFR testing and consumption. So we developed a tailor-made sampler, which is taking sample from every layer of the tanker. We developed this sampler in-house, and this is our testing equipment. We have full equipped laboratory for AFR testing. We ensure 100% safety measures in all the site of AFR. Now talking about raw material, we are widely using wet fly ash and slag as a raw material of natural minerals or substitute natural minerals for clinker production. Earlier, we used China clay in place of wet fly ash, and slag we are using red effect. So both natural minerals we are replaced, and now we are using wet fly ash and slag in raw mix. So total, if we see 2,99,348 metric tons we are used total raw materials during 2018 to September 2023. This is the overview of raw material consumption from 2018 to September 2023. We are approx consuming 4 to 5% of total raw material consumption of clinker. Now look at the utilization of slag. As I have already told that we are replacing red occur. Earlier we used red occur as a natural minerals. Now we 100% replace this red occur with slag. Slag is a byproduct of Hindustan Zinc Limited. And if we see chemical analysis of slag, is 35.3% is alumina content. So this is helpful in our maintaining liquid content. Now, utilization of bed size is also replacing China clay. Earlier we used China clay for maintaining our alumina content. So that replaced with IS and 47,328 metric ton price we have used. Thank you.
For this journey of AR path for the new plant. So we belong to JK organization, which is a reputed company, diversified company in the now India, JK paper, JK security, JK finance, certificates and all. So I would like to share here that the JK Lakshmi cement is committed towards net carbon initiative by 2047. So it's our heartening, let's say, companion towards the energy efficiency and sustainability with Parlikar. And I will glad to share that our plant, the total electricity consumption, about 80% of our consumption is of renewable energy. It's up from solar and wind. So some of the milestones from, you can say from the group unit is, it stands among top 3 cement and also we have been awarded so many awards for the system also for the electrical. The category we have applied here for is for TSR. So for the cement, it's a vital component of global infrastructure, and hence the thermal substitution plays a vital role in, let's say, for cement manufacturing and saving our environment. So we have invested in state-of-art biomass industrial base. We are harnessing their potential to replace the conventional fuels. This is not only reduces the greenhouse gases, but also align with our commitment towards future sustainability. So I will not talk much because already so many persons have talked this. The time is here to for the future capability and future. So this is the brief about our facility. Actually, we have a 20 TKO capacity, well conveyor systems and copper arrangements. Right now, we have limited capacity, and this system is later. If we are more of an automatic type of system, it will be able to feed more precisely for and will improve the KSR. For any system improvement, you have to do the SWOT analysis. Whether it's a system, whether it's anything what you want to implement, and that is a strength, weakness, opportunity, and threats. So for strength, as you can see that we have a good designer. We also have artificial intelligence installed in our field. So at the same time, we have some weakness which we have to work it out. We have to come over it. So there's a lack of availability. This I was also asking the sir also that what the future you can see. So I find that the availability basically depends on the geographical locations. We are able to feed, but we don't have the availability of that. That is the issue. So based on the SWOT analysis, we are continuously working on our equipment, whether to install the how to optimize further, how issues what are which are coming in the by homogenizing by avoiding the issues. This is the past 4 years performance. Happy to share that we have reached up to 5.95% TSR with 18% by weight. In the major chunk, we are using the scooters, roller char, back filter dust, best. So we are not limiting ourselves here. We are benchmarking with all plants in Chhattisgarh. We are exploring what they are doing and what better we can do for that to be the best. This is skill trade journey. You can see that we are envisioning the target of 10%. which in future we have shown that these are the quality parameters. It depends on plant to plant what sophisticated equipment we have. Based on our plants, we have some quality specification we have made. This is just a potential feature for CO2 reduction for years. That 3% ESR is increasing. You have 16,700. So these are some of the potential by percentage additives, and reduction of obesity, which is a big opportunity for the
To all the cement manufacturing companies and RDO companies, they are demanding a bulk amount, and there are many companies who are also the small amount, and they also face some. So, what can be done from our side to help them get the value chain perspective? This is my question, and if you all can give me insights, that would be great.
that the better answer by sir only because it's a logistic chain and all.
Right? I mean, basically, they can be small suppliers, they can be big suppliers. Right? Big suppliers are like whoever is here, they are very big. Whereas there are also small players, small towns. They are also segregating and they are also processing it there. They have made smaller investment. Only question remains is the vicinity of the cement plant, which is facility. If the vicinity is there, the small players are able to manage economics and are able to supply. If it is pretty far away, then it is very difficult. They cannot sustain. The operations do not sustain that kind of spending of the economics. Whereas the big players can, because they have got more cushion in terms of managing the and due to the scale of operation, managing the economics. So, what can be done, I think, is there has to be a policy intervention where the small players, they should be methodology to kind of aggregate that, with mass and then send it to the user industry, which probably needs to be incentivized. Or there can be some other mechanisms to be placed, logistic mechanisms to be placed by the government. These people cannot afford to do it. So that seems to be one. The second one is, they should also be provided with some subsidy, deal with the concerns, of transportation and the viability gap that they have got. And if there are any industry bed around these towns, these solid waste management rules anyway, mandate use of up to 5% the replacement of fossil fuel. So some mechanism will have to be brought in by the district or the industrial state management to ensure that this gets diverted. So that instead of fossil fuel, this will be utilized to the extent.
But when we talk about the different terrains, like say northeastern regions, then down there are Himalayan places. Also, in that particular terrain, how can that be developed?
So if the industries are there, and if they are utilizing fossil fuels, then this obviously can be done. But if they are not, suppose the power generation is from hydro only, like most of the Himalayan is hydro or solar, then that option is not available. In which case, I think some other options but I'm not very sure how. But looking at the experience of, for example, L3, they are able to transport it to 1,000 kilometers. And still it is workable, viable. So from such region, if the policy interventions are brought into transport and made available to a distance of say 1,000 kilometers, by either viability, yeah, that's also a friends. I think we have had how many? 8 presentations. I hope each one of you at least may not have understood fully. I not expected also, right? But I'm sure you have appreciated, right? That there's something which can happen with waste. When I was given an opportunity to start utilizing waste as my career option, I willingly did that, and I enjoyed my journey all along. I served this particular sector for more than 25 years now. The day I started to take up this as a career, many people had said that you are going to get doomed. Right? There's no career option, such waste management. It's useless field. But today I think that is the field. Like you had banking, commerce in the earlier days, then you had software. In the later days, you have now waste management. And you have circular economy. Right? So these are the, I think, new areas which you should be keeping your antennas open and looking at options, career options, and there are many, right? So, and you have here so many people who make presentations. I'm literally talking to you, student community, who can offer you possibly good, job opportunities as well. If you show your passion to do something, you really want to make a career. And in my tenure, I can tell you all these, probably about more than 200 students, I had the opportunity of engaging and converting them into waste management professionals. Today, they're all there in various industries, India and abroad. It's a big career, very satisfied career. Just to give you a different view of the waste management sector, right? Otherwise, it's a very smelling and dirty kind of way. Appears to be. Very yes. Anyway, thank you so much. You've been very patient. I'm sure you have learned, and we all actually enjoy presentations given by everybody.
And remains here in the room. As we end the session, I would like to extend my gratitude to the chair, to the co-chair, the hall managers, and of course, delegates who contributed to it today to the wonderful session. Not to forget the MBA students in the session. Thank you for gracing us. And with this, we end the first session on day 1 of the international conference.